This conference will now be recorded.
Right. Today's concept is indexing in Mongo. So we discussed about crude operations, reviewing the deployments, how you review a deployment before you do it, and we also discussed about schema design. Like Mongo accepts the data in any format. Like you don't it won't restrict the document can come in any shape, but sometimes you have to control it. So how do you control is the last class discussion, the schema design. You can keep the validations, you can your data go through the validation, and if it rejects, it rejects simply. So these are all an architectures we covered, right? We are into the fourth topic, especially the indexing side. So indexing everywhere, including RDBMS, are like every database product need an index to identify the data uniquely with a better performance model. The efficiency of the system can improve when you select less data. How do you select the less data with your conditional statements when you have the pointers to the data? How do you get the pointers to the data? Only through the indexing. So let's go through good example to understand, just to focus today and tomorrow so that you get the full understanding of what is indexing. It applies every product. Whatever the product you are working, this applies. Okay. Just understand. So now show DBs to find what databases we have here in the Mongo, and to connect any database, I can use the database. So I have these many databases. I'm connecting to class database. Okay. And then to see the collections, show collections. This will display all the collections. So what I'm going to do, I'm going to load some sample data to play around. So this is the data I want to insert. Okay, so I'm inserting the data. Now, if I go and do the CLS, if I check the student data, this is how the student data look like. Okay, we have the some existing data. Wait, then I'll use db.student dot drop. I'm dropping it and I'm going to insert it because I need this data purely to make you understand the indexing well. Maybe I'll make it a little smaller so that data can fit into the screen. Right. Okay. This is not still fit into. So let me drag this side. Right. Right. Let's see the data at least now. So now this is the data I have. Okay. I have S number one, S number two. There are four twos, and here also six twos we have, and with three we have these many. So assume a case, data can be in any format in the Mongo. But when you're reading the data, how the background system is reading the data, we need to understand that part to understand the performance tuning. In fact, we will have good performance. How do you trace the load, how what is causing the load, and what is running the longer operation. We're going to track all that in the further classes. But to all that consequences, what are we going to face? The bad queries are just because of the indexing in the Mongo. No other performance tuning we can do except the indexing. Plays very bigger role everywhere. The indexing plays bigger role. That is a known thing, known topic to everyone. But in the Mongo, if you want to tune your query, you have to introduce the index only. That is the only thing you can do. There is nothing else you can do much because of all other things comes with the configuration itself. Okay, but anyway, first I'll cover the indexing, then we'll go through the administration, then we'll start the performance. When I start the performance, yes, these topics are going to be recalled again anyway. So now example db.student.find. If I'm reading the data here, s number one is a condition. I'm giving a condition. I'm calling the database DB means student is a collection name, find is a read operation. I'm giving a condition where s number is 1. If I hit this one, I'll get only one record because it is matching on that one record. But does the system is reading only one record in the background? That you need to check. So you need to check that one. Plain execution starts. So if you want to see how the system is reading in the background, you have to use this one. Okay. Student.find. I'm giving the condition first. You have to pass entirely, then you explain. If I just give explain, okay, if I give only this thing, it won't give the entire details of the execution plan, in fact. It is saying that collection scan good enough. This is saying that it is scanning the entire collection to give you the data, but how many records it is reading it, okay? So all that we know, how long it is running, in fact, if you see that the duration of the query is not here, in fact. So to know that in detail, I need to use execution stats. Execution stats. If I run this one, it gives you more information about how the query is running in the background. Okay. If you see, there is a query you are running and the equality condition one. Someone is not on mute. Can you go on mute? Uh, right. Oh, where is fine. So go on mute. Who is not on mute? In fact, for the first one who joined without a name. Naidu, you are not on mute. Fine. So now, guys, I mean, this will be, for the first time who joining today, will be a little bit tough to follow, but follow it. It is simple anyway. So I'm reading a query with some condition. This condition actually reading, it is going through the collection scan. Scan means reading every data from the collection, not just one record. How many documents you are reading? You are reading 13 documents. You have total 13 documents, but you are returning how many? One document. So to return one document, here I have only 13. If I have 1 million records, 10 million records, it will read all 10 million records to give you one record. Why? Because it doesn't know to reach that one record because it does not have indexing. Index is not there on that field. That's why it went with the collection scan. It is reading all the documents, giving you one document as a return, as a result set for you. This is not efficient plan. By looking at this, I can say that this query, what they are running, is absolutely bad because it's reading everything, which is not good. Okay. To not to do that, what we have to do then? We have to introduce the indexing. Okay. So if I go here, this is the data I have. I want to create the index on this field. db dot student dot create index. Create index is a command. And what is the field I want to create the index? In fact, here S number. One means ascending order, minus means descending order. So the data will it will keep the data in the order 1 2 3 4 5 6. So if you see 1 2 2 is here, 2 is here, it is not following the sequence, but index will follow the sequence. So how index works in the background when you create, let me explain the diagram a little bit. So I have the sorry. So I have the physical data like this. Example, I have 1, then 2, then 4, then 8, then 9, then 10, then 3, okay, then 6, something like this. If I create the index on this, data physically is not in order. If you see, the data is not in order. But if I, this is S number assume a case, okay, and this is S number index I am creating in the ascending order, lower to higher. It will create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what exactly it is doing? The data you see here, the physically is not in the order, but index is keeping the data in the order as a reference. This reference is coming here, this reference is coming here, this reference is going here, something like that. So wherever it is. So it actually, it knows the sequence of data in the order it is keeping and where the data physically fitting, where sitting in the actual hardware. So if I read the data here, data comes in the sorted order by default. Okay, data comes by default as a sorted. If I'm sorting on this one, I get the sorting will not happen in the background because sort is already there with the index. Okay, if you don't have index, it will scan the data. If you are sorting the data, whatever is scanned, again it will sort the data. Double the operation when you sort the data. Okay, if you don't have index, it is a double operation. Why? Because first it has to get the data into memory, then it has to sort the way that you want it because data physically is not sorted, right? So indexing will help in many ways, in fact, to to better use your queries efficiently. Indexing very important. So I'm creating ascending order index, not descending order. So lower to higher. So it says this one, see guys, number of indexes before is one, number of indexes after two. So which means that your index, what you try to create is went fine. OK1 means always success. OK0 means it is not successful what you are running. So this is a statement we see in a lot of configurations. OK1, OK0. OK1 means what you are changed in the configuration, it is successful. It applied to the system. If OK0 means it is not applied. Why it is so? We need to go through the logs, the error log, the Mongo log, and find the reason and rectify the issue. We will see that. We have a discussion going forward anyway. But for now, I just created an index. What is the one index we have is a default index and the ID field. This field we said like it is a default. You cannot avoid that field. And we discussed what exactly this ID mean, how it is going to help us. We spent time on that already. So if anybody is sorting the data on the ID, it is by default sorted on the time, not on the data. So basically you need to sort on based on the data, not on the time anyway, most of the time. So if I want to sort the data, like in the number from lower to higher, I will go with this one. If I sort the data with the time here it look for this latest data, this oldest data. So it will keep as is. So the difference definitely will come. So you sort the data on the user data, not on the ID data, in fact. Okay. But ID will have one index by default. DB dot to read the indexes. What are the indexes we have? Get indexes. Get indexes. This is telling you what are the indexes we have. One is ID field index, one is S number field index. So I just created an index on this field because I was trying to read the data with this condition. So always conditional fields should be covered under the index. Even in the RDBMS also, the concept is same. If you are reading the data with any condition, that field should be covered under the indexing. If not, it won't use the index. In it, you don't have index first, it will not use the index is different story. Then it'll go with the scan, then it is reads the entire data, it will choke the system, which is very bad. Now I created the index on this field. Okay, now if I try to read what happens, let's see, db.student.find, and giving the condition what we had already given in the last use case. Now if I go and explain and see the execution plan, how it is changed as we have the index on it. Now, if I read it, first thing you look at, it went with the index scan. This itself is at least 90% of the performance you saved. Index, when you have 10%, still you have the impact that I'm going to cover right now. But index scan is something, okay, you see in the execution plan, there is IX scan, index scan. You have only two things in the Mongo, collection scan, index scan. Index scan again will have a key lookup, so we'll talk about that. But here, the index scan is something is 90% of the performance you saved, 90% at least, which is good, right? Which is obviously good. But what you need to look at when you see the index scan, you need to look at this one. Total documents examined. Total documents examined. And how many document is written? One document. How long it is executed? Total in the execution time. Total it took how long to read the data? 12 milliseconds. 1 second equal to 1000 milliseconds, right? So out of 1000 milliseconds, it took 12 milliseconds to read the data. So actually, first time when it reads data, it takes longer. If I reread the same data, the time what it takes to read the data will be lesser. See, 0 millis. Why? Data got buffered. First time it has to go through the allocations, it has to look at the locations and all. It takes a little longer, but it reads exact data what you wanted, which will not create the IO issue, CPU issue. It won't make the query to run longer. Everything you're saving it. The expensive resources are CPU, memory, disk only. You're saving everything because you're reading limited data from the background. Okay. So you are going with the best execution plan here. You're going with the index scan. You're giving a condition, it is reading one document, giving you one document as a result. So this is so absolute perfect execution plan. So this query is absolutely good one. Now let's go to the use case slowly. Ask some questions at anyway, to whether you understood all this thing or not. I'll explain again. Then come to the conclusion on the this part. I'm reading data. Understand this. This is an intentional question. I'm giving S number two. S number two. How many we have? One, two, three. One, two, three, four, five. We have five. Now name Pawan, and Vijay. Okay, I'll give it this way. So some very good example. I'll go with the Vijay. So how many documents it will read? Can anyone tell how many will come out at least? If I read that condition, how many documents will come out?
Only one.
Only one. Nice,
Only
very
one.
nice answer. Nice. But how many it will read in the background? What do you think?
It will read five. Five it will read.
Right, nice. Very nice. Why five?
Because yes, number two, it five are there, no? So it will read five.
Nice, very nice. You have the indexing idea then in that case. So you have five documents. The indexing is on the S number only, not on the S name. So it sorts the data, it gets the data on this field at least. It because it knows where it is, in fact. But the second field, it doesn't know where it is. So on the first field, it use the index, and the second field, it doesn't know, so it will go with a key lookup, kind of. So if I go here, if I read it, if you look at if you look at here, first thing, let's come from the beginning. It is saying index scan, which is good. You are giving the filter here. Filter is you are filtering on the name, you're filtering on this number. Good enough. But here you see it is reading six documents, but giving you one document. This is not good. I have very less data here. Within the very less data, I'm getting only one record, but it is reading six records. Understand, I have 1 million records, and this kind of combination of data is there. Then you're always reading the bad data. You're reading bad data because it is only getting you one record, but you're reading six records. The other five records are bad for the query criteria. It is not covering the entire data that I'm trying to fetch out, right? So, which is something is not good. So, in that case, you have to go with the composite indexes. db dot again, db dot, sorry, student dot fine. So, what I'm going to do, I'm going to create the next index. What I'm doing is a bad again. I'll conclude that it's a good. It looks good for you, but I will conclude it. You keep create indexes for everything, then it will create another mess. But how you conclude that one index covers every criteria? So that is ultimate thing you need to understand. But anyway, so now what I'm going to do, I'm going to create the index. Create index. I'm creating the index on the S number one in the ascending order. S name one also. It is also ascending order. I'm creating an extra index to cover two fields now. So we have three indexes now. One is default, two just we just created. One is on this number, second is S number and S name both. Now the same command if I run this where it was this one I was trying to read. Previously it was reading five records and giving you one record out because only one matching with this condition. It will read only one document now. It won't read five. Why? See, when you read the execution plan, how you need to read, first filter. The filter will be in the beginning itself. How many fields they have? Two fields, S number and S name. It is going with the index scan. But index fields, you see this one? S number covered, S name covered, both covered. Then if I come to the record count, it is reading one document, giving you one document. It took 4 milliseconds to execute the data, right? So it is efficient, maximum efficient what it can. Why? Because it is reading exact pinpointed data what you wanted. Unnecessarily, it is not reading any data, which is good. Now again, let's go to another case. So now I'll conclude it, guys. This is what in RDBMS also people do the mistake, in fact. So they don't know that how the indexing has to be created. So now I'll take one more good example. So you have to tell me how many it will read at least. db.student.find s number one name, not s number one, s number two. Let's go with the two only. Just let's make a scenario. Okay. Okay, this is very good example. Okay, absolutely nice. So now what I'm going to do? Pawan. Fine. His name is Pawan. S number two is okay. That's good. And I'm going to give one more field as a criteria. Right. So how many documents will come out with this condition? Because we have limited, you can say that. How many documents it will read out?
Only one.
Only one. Nice. How many documents will read in the background? If you say that.
6.
Six. Why six? You have the indexing on two fields. This it knows where it is. This also it knows where it is.
Only four it will read.
Nice. If you say that four, yes, it's nice. Why? Because see, we have the index on the S number, we have the index on the S name. So S number, it will try to read six, but S name, it knows again where it uniquely. So four, there are four Pawans. So it will read four. But in the address part, only one address is Hyderabad. The rest are all Bangalore. So it knows exactly these two combinations, but third combination does not know. So it will read four, give you one record. So let's see that execution plan, in fact. Execution starts. Now, if I go to here, first come from the beginning, we have three fields under the criteria, okay? And it is trying to read with the two field index, see S number, S name. It is going through the index, which is good. It is going with the two field index because you don't have a three field index there. Now, if I go back to the actual data fetching side, it is giving you one record and reading four records. This is not efficient. It's not efficient. So in the real time, data is versatile. You don't know how the data is laid out. You only know the execution plan by looking at the execution plan. You can say that your query is wrong straight away. I don't know what is the logic they have written, what they followed inside it. But if I look at the execution plan, I understand, okay, this query is not following the indexes and the fields, they are filtering it. I can clearly say that even they have the index is not fully covered the criteria. So how do I don't have to look at all this. If I look at this itself, I can say that, oh, it is reading more data, giving you only less data, which means the fields what they are keeping under criteria, that all the fields are not covered under the index. It clearly says that. That's what that means, in fact. Okay. So reading the execution plan is important. How you understand it is important. So this is something you need to catch in today's class itself. Okay. Anyway, I'll go with the many more examples to make you comfortable on this. So try to follow. So now db dot student. This concept applies in any product, guys. Any product, like to you name it, it applies. Now, if I read the same data, what I was reading in the last case, because we have the index. Oh, I did not create the index. I'll create the index on three fields now. First, create index. So you keep create indexes like this. Is it a good thing? No, it is also not good thing. But what is the ultimate solution? Next, I'm going to come to that. Okay, because creating too many indexes, it's heavy. It is going to even like data is 10 GB, indexing data is 20 GB. It is possible because you are creating that many indexes with every probable criteria, read criteria. You should not do that. So I'm creating third index on the data side. It will be fourth index anyway with the default. Oh, what are you saying? Just a minute. Oh, sorry. It should be address, not the S name.
Ravinder, if we are having a trillions of record, then how we are going to create the index then?
uh, trillions of record, it takes time, but you have to create it, right, to support the read operation with a better execution plan. Yes, it takes time. How do you create? The command is same, but you create in the background that I'm going to come as a best indexing model. It comes tomorrow, but understand the basics today. When I have 1 TB data, if I create the index, it takes 2 3 hours, and it will block the other operation, because the indexing in the Mongo, when you create, it is purely offline. There is no online in the Mongo. In SQL or RDBMS, we do have online indexing. We have offline, online, both the concepts. In Mongo, there is no offline. Sorry, online we have it. We have to take it different way. I'll conclude that at the end of the indexing model tomorrow. We have online, but online, unlike RDBMS, it is bad in certain cases. It is good certain cases. Both the cases I'll cover. So how you make the indexing to run only in the background, not to interrupt the user workload. We will talk about that tomorrow. First, let's go through the indexing basics first. Then I'll explain you the entire background thing. That impacts the applications, right? You keep create index. You cannot just create index on the fly. Just I'm talking about here. I'm creating. I'm showing. But in the real time, you cannot do it. So how do you do it? There are two ways to do it: offline to impact the entire application, or online. Online, anyway, it has advantages, disadvantages. Unlike RDBMS, it is different thing. In the Mongo, it will follow a different model, which is equivalent to resumable indexing. That I'll compare. I'll tell you. Don't worry. But let's cover the basics first. Then I'll definitely come to your question. When you have a more data, how you deal with? I have just few records. I'm just showing and moving ahead. Will it happen like this in the real time? No. You don't have this less data in any of the collection. But understand the basics, the principles. Then we'll go that side. Okay, what is the issue can going to face? Okay, I'll come to that your question. Don't worry. I'm not skipping your question. I'm going to answer. Now, if you see this one, now I'm reading these three records, and it is going to read only one record in the background also. If you come to here, you have three fields in the criteria. Good enough. It is going with the index scan. This itself 90% good. Now, if I come to here, so it is reading one document, total documents examined. This is important. Should always read a total documents examined written. This is going to tell you. Okay. The execution time, how long it took to execute, 1 millisecond. It always the value is millisecond. If 1,000 milliseconds means 1 second. So that way you have to calculate here. Always it gives in milliseconds only. So now total document. This is what your concentration should be always. Total, how many it is read in the background, how many it is returned to the application. This is very, very important component. It is using the index, it is reading how many documents, it is returning how many documents. This is very, very important for us. Okay, fine. Now, is it good idea to create these many indexes? No, right? It's not good thing. You're not doing good thing. Why? Because you are really, taking all the storage for index itself. Is it a good? I have these many indexes for small chunk of data. So creating too many indexes is also a non-performant. Like, you're making your DML slow. Too many indexes, it has to update everywhere the indexing, reference indexing data of that column. So DMLs will get slowed down. Your reads will go fine, but DMLs will go slow down. So that should not be the case. Again, more indexes, more data. Every time you it has to refer the indexing data, right? So the heavier to the system to manage as well. When you do the rebuild, all that, the more indexes, more time it takes. So you should not do that way. You have to think a index which should satisfy more patterns, not just one pattern all the time. Okay. So now what I'm going to do, I'm going to drop these indexes. The first one field index, two field index, and then I'll read the data, and then I'll ask you the questions. Okay. db dot collection name dot drop index. I'm dropping index. Anyway, I'm going to give the notes. I'm just giving the basics now. Notes I'll follow. We have the notes. I'll run through the slides. I'll give the notes, but understand the concept. This is important. Notes in the sense that what patterns will cover what. Dropping index, creating index, all maintaining index. For that, I'll give a notes. But understand is something does not have notes. Understanding is important. So now I'm taking this index name, putting it here. I'm calling the collection. I'm calling the index name, drop index. So it will be dropped. You had four. Okay, one means you have three now. So if I go and read again, the S number index is gone. What was I deleted? S number underscore one. Ah, it is gone. So now you have this index. So I'm going to drop that one as well. Index name. What went wrong? No such
Yes,
command. Get in. Oh, sorry,
get
sorry. It's
index.
a, it's a drop index. Sorry, my bad. It's not be great in there. Literal not terminated. Oh, sorry. Come on, what? Fine. Now db dot get indexes. Sorry. Yeah, double quotes. Correct. So get indexes. If I read the get indexes, these are the indexes. One default index, one user index, what he created. So now let me go through all the pattern. One index right now, db.student.find. This is the data we have. If you are reading everything, there is no meaning of index. It doesn't use index because you're reading everything. It go with the scan only. Scan is a good efficient operation when you're reading everything because indexing it has to go to the index tree. It has to check the intermediate trees and then find the leaves. So it is a heavier operation to the system. So it goes and scan all the pages and get the data out. That is more efficient. So that's why whenever you read everything without any condition, no indexing work. No indexing. That's how it is. Systems everywhere. If you want, I can just show you with the example of here also. But anyway, so I'll cover that right after this, if you for your reference. db dot student. If I'm reading the data, S number one or S number two, how many it should read? We have six, so it should read six only, not all. Now, if I go and see the execution plan, explain execution plan. If you say this, I have only one field as a criteria. It is using this index. What I am more focused on this is it reading the six document, giving you the six document. This is efficient, absolutely efficient. It is reading how many documents it want. It is giving you how many documents you wanted. Good enough. Now, if I go and read again, db dot uh, student- now db dot student dot find s number two, s name one. How many it should give? Vijay example. How many should give? Only one. You have Pawan, see, S number two, 6, but Vijay is only one combination. You have Pawan 4 and one Ravinder, one Vijay, total 6 documents. But I'm giving on the second one as a Vijay. So how many documents will read? We have the indexing on first name, first field, second field, third field in one index itself. So it's going to read exactly one document. I'll conclude it. Come to the conclusion side. First understand. Now we are giving the criteria on two fields, S name and S number. It is going with the index scan. This itself is something good for us. It is going through this index. What index it is used for this read operation also it will display in the execution plan. Now, the next important thing we need to focus is how many documents it is reading. One, giving it one. So now I'll go with the other criteria again. So now find db dot student dot find. I'm giving the criteria as to s name per one this time. Okay. Then address. Address, I'll give it as Bangalore. So how many will come? Please, how many records it should read? Look at the data. We have only four pawns. So how many should read? Three,
3.
right? Right. It should read three. You get the three only. But if I look at the execution plan also, it'll read only three. Why? Because all fields are covered under the index. It knows how many it has to read exactly. It does not read unnecessary data because indexing has the references exactly where that combination of data is sitting. If I go and read the data, see, the address field, the sname field, s number field, and it went with the index scan. Good. And then you look at here, three records examined, three records returned. So you read data with all three combinations. One index is covering all combinations. So understand this thing. Creating S number one index, S number, S name is one index, creating S number, S name, S address is another index, is equivalent to one index because all patterns are covering this thing. But what if the case I have designed here, this is the data we have. I have the like index like this: S number, S name, S address. If I read only S number, will it read it will use index or not? We just have seen already. If I use S number as a criteria in the find condition, will it use the index or not? Yes or no is only question. Hmm. We have seen why you guys not telling anything. So if I'm going here, I'm giving S number 3, just to assume a case. Will it use index? We have the index on S number, S name, S address. So
No, it will
as
not
long as
use.
why it will not use?
Because S number 3, no, indexing means
Oh,
we have given for S number 1. It will take.
will take. Why not?
Because
It doesn't matter what you are assigning it here. So execution plan, execution stats here. Do it. You see this one total three documents read, three documents given. That says that okay, it went with a fine execution. Okay. So if I go with the one field with this index model, it uses the index, absolute index. If I read only this field, will it use the index S name? Only S name I wanted to use it. db.student.find. Will it use the index? There is a rule for indexing, if you know it. It is there everywhere in Oracle, SQL, whatever the product you are working, this rule applies everywhere. If I read the data on the second field, will it use the index? Though this field is covered the index by the second field of the index, not first field of the index. That matters a lot. I'm giving it as per one example as name. So four records you will get it output. But in the background, how many it is reading? That's the question.
it will read entire the document, whatever it is there.
Very nice. So why? Okay, you said is
Because,
correct. Why?
because we are giving S name equal to like
Hmm. Okay.
S equal to
So
power.
yeah, so you are giving as a pawn as a criteria. It went with the collection scan because no indexing is starting with that field. Whenever you want to use a composite index like this, you have three field index, two field index, whatever more than one field, the first field of the index must be called in the condition. It can be anywhere. It has to be called. Else, it doesn't know the index because the first field is not called. Let's use a SQL Server. If you guys from SQL Server or any RDBMS, just for the use case, I'll give you an example here. Example. Um, any random data I'll take and tell you this. So basically, when people read data, the good developer or like who knows the standard, they should read the indexes. What kind of indexes they have on the table first. Then only they have to use the things as a criteria. Help index, which will tell you what are the indexes we have, and on any of the table, randomly I'm picking it. Example. Let's use this one. when you use this one, you should not separate it. You should keep it this way. So if I read it, this table, that schema, hmm let's go. The separation. Why it is not reading? Oh, I should be in the adventure works where this is in fact the table, right? This is a schema. This is a table, right? Now it is reading you your indexes. You have two indexes. You have two indexes on this schema, this table. So where this one is here. This is what I pulled out. Now if I go and read that particular table, this one, right? So now understand. I'll enable the execution plan. This is how the execution plan. It went with the index scan because you're reading everything almost. Okay. Um, top 10,000 records I'm reading it if I'm reading it. So it is going with the scan operation. So now let me take out all this. I don't need this. I'll go with the fields will be covered anyway with this asterisk also. Okay. Not to confuse with more fields and more complex. Let's make simple. This is a query. If I'm reading this, come on, 8,845 records, and oh come on, I did not actual execution plan. Let's go with the actual. Include actual execution plan. If I see the execution plan, it went with the scan. Why it went with the scan? In fact, you're reading everything from the table. I'm not giving any criteria here. Okay. When I'm giving the criteria, I should know this. What kind of indexes they have on what field. So if I use the, see here, this is something is an index. Index is covering two fields. Index keys means fields. Purchase order ID, purchase order ID detail. So I'm giving purchase order ID first to read as a condition where purchase order ID. This one. This is the first field of the index equal to. To give that one, I need to have the data here. Purchase order ID. Follow this because I'm going to take this as an example there. Purchase order ID, I'll give it 8. Where purchase order ID equal to 8. Now it will use the index seek. It uses the efficient index seek. Why it is using index seek? Because it knows the index. So the objects here, PK purchase order details. What is index it is using? It is going to tell you on the object. It is using the index what this one is actually. This one. It is using this index because you are calling the first field of the index. If I go with the purchase order detail ID for any reason, okay, I'm going with the this one instead of the first this field detail ID here. Here I'm giving it 11, whatever. Okay, 11. What happens in this case? It will go with the index scan. Why it will go with the index scan? Because this field does not known to the system as an index. The first field is missed. If I give this one, comma, and purchase order detail equal to 8, I am using this non-indexed field, this indexed field in fact. Okay. If I run this one, oh sorry, what is a mistake we've done? Purchase order ID, here it is, 8. Right, you see this one on record. Now it went to the seek. It's using the index. It is only reading one. If I go to here, come on, it goes away. Number of executions, number of see here the what how many records it is giving out. Number of rows it read, one record only. Here I cannot point out. It will go away. But you need to look at that storage number of rows, actual number of rows it read, all that one record. In fact, why one record? Because you have covered the first field of the index in the condition. If I like don't use this field, you don't use the index, as simple as it is. So if I'm going only with this one, the indexing field does not know to the system, though this field is covered under the index, but it is covered as a second field of the index. So it does not read the index. Okay, that will be a problem. Index, it went with the index scan. It is asking you to create a new index for this field because you're going only with one field as a criteria. Okay, so now come to the Mongo. That is what exactly I'm trying to point out. If I'm reading the data on the field, which is not the first field of the index, though it is part of the index, but that field is not first field. You have to definitely use the first field of the index. So if I read this field, will it use index? And the only S name. You have to tell that. We just have seen. Yes, no.
No,
No, very nice. If I use only S address, will it use index?
no,
Very nice. If I use this one, will it use the index?
yes,
Yes, good.
Yes.
So the reason why it uses index, I'll come to the conclusion anyway. So there is a I kept all these patterns to conclude towards indexing. Okay, all the criteria when I make you understand, then you can answer the ultimate question. db dot student dot find. Okay, let's not say yes or no, just understand. I mean, in reality, that's a good thing, right? So now if I go with the Pawan, as see, I don't have to keep the S number as a first field only. It can be anywhere, but it should be called as a condition. Then only it'll read it. So S number Pawan, S name Pawan, S number 2. So the first field on the index is called. It can be in any order, anywhere, doesn't matter. It should be there in the condition. That's the point here. If I give this one, you get the 4 records, but it only reads the 4 records in the background. It does not use more because first field of the index is covered. That's important. Execution stats. If I go and read indexing, it is using the indexing, and you go with the two fields are covered, and it is reading 4 documents, giving you 4 documents. Absolutely nice. This is enough. Mongo, you can only tune this level, nothing else. There is no other way to tune further. This is the only tuning we can do in the Mongo, in fact. That's why indexing is very important in the performance. Fine, anyway. So let me ask the other question. This will use a yes, yes, absolutely yes. Will this use the index? Should answer no. Yes or no?
yes,
Yes,
yes.
nice. It use the
Yes.
index. Very nice. But there is a something you need to understand. You broke the order. There is one more thing. It happens in the RDBMS also, whatever I'm showing. You broke the order. If you look at the data, S number, S name, S address. But I'm calling S number, S address. The middle field, I broke it. When you broke the middle field, it will search on this one. First, it will only keep the search on this one, and it will go with a key lookup on this one because you broke the order. When the order is also not there in the condition, at least it use the first field means, and the first field it will sort the data. It knows it read all the data from the first field. It happens in any product. You are working maybe different products. In all products, the things will happen the same way. There is no difference. So when I'm omit the order of the index, I'm skipping the order. I'm reading the first field and the last field. There is a in between fields. So what happens in this case? Understand very, very carefully here, because this is what is a conclusion. All will have a misconceptions here. Whoever working for how many years doesn't matter. I've seen many people having a misconception here. I'm giving it as number 2. Then I'm giving it here 2 and Hyderabad here. And directly, I'm actually not giving the sorry address. I'm not giving the midfield address. Address only, right? Yeah. So it no need to be first. This one, it can be in the last also. Still, as long as the first field of the index is called, it knows okay. It need to call the index. Basically, how many records will cover? Give the output only 2. Oh, there are 2. Okay, we're giving S number 2 address. Okay, fine. That's good. So because we are giving the condition on 2, okay, it is going to first scan all 6 documents, giving you 2 records. But in the middle of the field is missed. Let's see the execution plan, and then I'll explain. Why it happens that way? Hmm. Execution stats. Now, first to go to the condition. Address, S name. What is the index is used? This is the index. But you see this one, S number is the first field, S address is the last field. You can say that okay, index order is broken. Good enough. Now what happens? You see this one, it is giving you only records, but it is reading 5 records. This is called key lookups. In the Mongo, we'll call it as key lookups because you broke the order. It is a good, in fact, 90% of the performance is giving good, 10% is bad. Why? Because you broke the order. Now, it used the index, yes, but with key lookups. This is what you need to say. Okay? It used the index, but with key lookups because you broke the order of the index. The order is S number, S name, S address. See, this could have been, if example, S number one, S address, and then S name. If I would have called all three fields in any random order, still it use index because all fields are covered. It use absolute index. Will this use the index? It's a question again.
Yes.
Yes.
It's key lookups or without key lookups?
Without key
Without
lookups.
keyloop.
Nice. Without key lookups. Why? Because the index fields are in the order. It does not go with the key lookups. Okay. With this combination will use the index or not?
No.
Yeah. No.
No. Very nice. Why? Because why?
First one is not there, right? Serial number.
Right. That's simple. First field of the index is not called. Absolutely, you don't use it. This one?
Yes, it will use
Hmm.
with key lookups.
Right.
Key
Nice.
lookups.
Nice. That's what I'm expecting. Anyway, I'll conclude at the end. This thing I'm asking, but conclusion comes at the end. So, will this use index?
No.
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 No. Nice. Will this use index?
Yes.
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 Nice. This one? The other
Yes.
combinations?
Yes.
Yes. Oh, come on. Okay, let me type then. So yes, yes, every combination. These are all different patterns. What if you observe that one? Every pattern is different. They're not same. Here it started with S number, S name, S address, S number, S address, S name. Every combination. So total, how many combinations we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 different ways they can read. Yeah, it is probability is there. How they are reading it, they just keep the fields in the like condition and read it. They want the output. That's it. The developer mentality is only they wanted to get the output. They don't know how to keep the fields in the order. That's why it took all the combinations. What is possible with the three indexing field? So with one index, how many patterns it is covering? If in fact, except three, right? Except three, all other patterns are covered. Except four, in fact. This also no, right? So out of 12, 12 or 14, how many we had? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Out of 15, 4 patterns are not getting indexed, but 11 patterns are getting the index. Think that way always. Creating index on one field, second field, all other fields, individually is not a solution for you. That is not going to work for you. You need to understand the application nature first, like nature in the sense that how badly they're pulling the data. It is a read intensive, write intensive. Write intensive means try to introduce less indexes. Read intensive, try to introduce more indexes. This is something How do you know that write intensive, read intensive? I'll tell you. We can find it in the Mongo. It is write intensive, read intensive. We understand it within the system itself. Write the parameters. Using that, we understand. Okay, it is going the more writes, less reads. More reads, less read. We can find. I'll show that. But the more index means it is going to support more read operations. The more writes is going to suffer. It's common. So the balance where you are going, the read side, because the read intensive product it is, read intensive server it is. Okay. I'm creating one index, but it is fulfilling 11 different patterns. So this one index only I'll prefer. I don't create individual index anymore. We need to educate the developer. They need to see the index pattern first before they write the query. Like this, they have to see the pattern. Okay, this is an index. Index is covering these fields, but the first field need to be called in the condition. Then I get everything. Okay, then I will get everything as I using the index. If they have to go with the purchase order ID detail only all the time, many a times with that condition, without one field, go and create index. There is no other way. But try to be avoid unnecessary creating index in every field. Create one index which covers the most of the patterns what they're trying to read. Getting the point? Every product, this applies to every product, guys.
Yes,
You
yes.
put
Whatever
in
the
SQL.
fields that we require, that we need to create
mm,
on that one.
right, that need to create, and they need to know the pattern also, how to call the fields. Okay, they need to know the
Yeah.
fields also, how to read the real index. So this applies everywhere. Whatever I'm saying here, this applies absolutely everywhere, not just in the Mongo itself. If you understand this basics, we are good to go ahead and discuss. So there is one note I have to write. This applies everywhere, of course.
Okay, Ravindra, I have a few questions. So once you're
Yeah,
done with
go
this,
ahead, please.
okay. So
Yeah,
here
please go.
the index is the sequence of S number. Uh, go to your notepad.
Mm,
Yeah, S number and S name and address. Correct. This is
mm,
the
mm,
order of the key
mm.
columns.
Right.
So
Mm-hmm.
the first probability S number it works because it's the first column. Second probability
Mm.
S name it's you mentioned as no, right? But still it can do the index scan, right? If it is an index.
What do you mean by it? It does not use index because it is not calling the first field of the index. It doesn't know.
So Mongo only takes the groups in the index only if it is the first field is part of the querying column, querying uh,
Not only
in the
Mongo,
query.
every product in the market. Not only Mongo. That's what I said. I was showing this thing as an example in the SQL. I have the index on these two fields, right? Purchase order ID, purchase order detail ID. If I go with the purchase order ID, it will use index. If I go with the second field, it won't use index, though it is part of the index, because you are not referring the first field of the index. This rule is everywhere, not just
No, no,
Mongo.
no,
The-
no, not really. It can use the index. Instead of index seek, it can use the index scan. That's the difference. In RVMS, we have two things. If you are properly
uh,
using the key
uh,
columns, it can do index seek. But if you are not using the key columns and for example second key column or third column, it can still use the index, but it's called as index scan.
Index scan means everything here, not just one thing. Index scan means it is table scan.
No, no,
Equivalent index scan is equivalent to table scan. Okay.
no, not really,
If
right?
you have a
Let's say you are getting
misconception, go and
non-place
clear on
index.
that.
No, no, not here.
Hmm.
Index scan is not mean table scan. Non-place index scan is not mean a table scan. It just means the index scan and probably some key lookup. That's it, right? It's not still not a table scan.
Index scan on what, basically? On what field it is
So,
scanning, in fact?
okay. So let's say we have two columns. Let's say we have table
Mm,
have 5 columns and we have
mm.
index on 2 columns. And if we do the
Your
index
voice
scan on
actually. Wait. Can you keep your mic quite near to your because there is a something the voice is not clear. If your
okay.
question maybe I'll
Is it
answer.
better
Yeah,
now?
no, much better. Go ahead.
Okay, all right. So let's say we have a table has 5 columns
Mm,
and you have created an index on 2 columns in the composite way.
mm, mm,
Okay, first column is a column A, second column is column B.
mm,
Okay, so you are in your query, you are using
mm,
only column B. Okay, not column
mm,
A.
mm,
Still, it can use
mm,
the index, but it cannot do the index seek, but it can do the index scan.
Yes,
mm,
yes. That is
mm.
what he is saying.
That is what it reads all of your data of that particular. See, index scan means equivalent to. See, do you know the difference between table scan and index scan at least?
Yes,
What
yes.
is table scan? What is a table
Okay.
scan?
Table scan is you are scanning the entire table. Okay.
Hmm. Index
Index
scan?
scan is index scan is, for example, if you get an index on only 2 columns. I'm not talking about cluster index. I'm talking about only non-cluster index, which you are showing here. So if you are
Hmm.
doing index scan on the non-cluster index, only that particular object, which is only 2 columns, data structure will be scanned, not the remaining 3 columns.
Mm,
If your
mm.
select class has the star, then it can go and look up those columns, but that's a key
Lookup is
lookup, but
different. Sorry, don't talk about the lookups. Lookups is the only
okay.
thing. It is I'm calling every field. That's why it is going to lookup.
Yeah.
Lookup is a different
So
story
in this case,
altogether.
if it is a
Scan.
non-test index, it's only non-test index scan. It's not a table scan. So
Okay, go and
non-test
clear
index scan is not
one
equal
more
to
time.
table scan.
Okay. So see, index scan, table scan almost equivalent because table scan means reading everything without using the index. Index scan means reading everything using index. That is the only
No,
difference.
no, no,
You have
no,
to clear on
not
that.
really, right? Table scan is you are scanning the entire table with all 5 columns. It's a different data structure altogether. For example, your table is 10 MB. Table scan is you are reading the 10 MB data structure. When you're creating a subset of index using only 2 MB. So when you do the non-cluster index scan, you are reading only 2 MB of data. That is different data structure altogether. So
I
it's
don't
not
know.
as
I'm not talking
equivalent.
about this. Your focus coming here, not I'm coming. I'm focusing only on the index side.
Okay,
The
index I'm
number of
talking about.
fields is anyway. Just you have to clear it on that one. Just go ahead and check, please, because I understand your where you are coming from. I
Mhm.
know that even I was that concept misconception in the beginning days. Just go back and clear out on that. I would say revisit and we'll come to the discussion. Not an issue.
Okay, so that's
Fine.
fine. So can go to the notepad and because still I have a couple of questions.
Yeah. Why not? Go ahead.
Yeah. So here S number it makes sense. It's the first column. It is. So when we use S name equal to 1, so Mongo don't understand it is still we have it's part of the index data structure. It won't do the index scan. It will go for a table scan.
Which one? Which combination you are trying to talk here?
Not the second
The
one. Second
this
one.
one?
Second
Second
one.
one?
Second one.
Yeah, of
Okay.
course. It doesn't use.
Okay. So when we come for third, okay, it's the same as pattern. Okay. Fourth is works because it's a two columns are there, and S1 address is also works. So how about the S name and the S1? So it's because it's in a different order, but it's still using two columns. It's using it. Is it right?
Order doesn't matter. As long as you
Okay.
keep the fields, it keeps the order automatically.
Okay. Okay. So at any
Okay.
case, as per Mongo, the first column should be the key column. First key column should be part of the query. Then only it can.
Not only Mongo
Uh,
in any product. And you have to clear on that concept, please. Anyway,
no,
that's
that I
okay.
can
I don't
actually
want to
clear
debate with
you.
you.
Okay, that we can discuss it later. But I think I feel it's
Any
different in Mongo.
Okay, that's fine. That's fine. So
Okay.
just go and visit one more time. I would just advise you. I'm not anyway saying that go and revisit that concept again.
Okay, fine.
Anyway, so when we have uh, composite index key, indexes, we need to call first field of the index, first field of the index to use the index in the read operation. This something is very important. Okay, based on this field condition only, the SNO is coming out here. Okay, when you have composite index and multiple fields, we need to call the first field of the index to use the actual index in the read operation. Okay, that is a very important point we need to understand. Come back to the slides anyway. So whatever I discussed, again the things are here. That's why I covered in basics first, then I'll take you through the slides a bit quickly. So index supports efficient execution of queries in Mongo, not only Mongo, in every product. But we are talking about the Mongo, that's why we are saying Mongo here, but it is concept is same. Without the index, MongoDB performs collection scan every document of a collection. So if you're not using the, see, there are only two concepts here: index scan, collection scan. Index scan means it'll read the indexes which are part of it, and key lookup also it will be part of it. And collection scan means entirely anyway. If an appropriate index exists for a query, MongoDB can use the index and then it can limit the number of document it must read. So if you don't have index, it will go with the collection scan. It just reads everything what you have. But you have index, it will limit the number of records because it knows what it has to read, right? Indexes provide high performance read operations for frequently used queries. Yeah, of course, indexes will give you good performance read. Indexes are a special data structure, store the small portion of collections data in a easy to traverse from. So it is address of the location, data location where it is sitting, and it will build the B tree format to read the data, to reach the data based on indexing field. Fundamentally, indexes in MongoDB is similar to any other product. There is no great difference. Indexes we have many types of index in Mongo, like default index ID, which we don't have to worry about, but we have to look at this single field index, one field index. S number, I created index, I read the S number, I use the index. So one field index, there is no point of discussion much there. One field, you're calling one field, you get the index usage. Single field index. What we talked about is a compound index. Actually, we don't say here in the composite index, it is a compound index. We say the compound. Compound and composite is same. Don't confuse. But in Mongo, we'll call it as compound indexes rather than composite index. Composite, we'll call it an RDBMS. Compound, we'll call it as in Mongo. Just keep those words. Compound indexes. Okay. Multi-key index works on the array field. Text index works on the, as I was saying, if you guys remember, regular expressions are not good in Mongo. So the replacement of regular expression is a text indexes that we'll cover. TTL index I already covered, but I'll cover again. When do we use a TTL index? When we have to clean the data based on the age of the data. If I don't want some data, if I don't want some data which is not valid after a while, I don't want the data like machines, applications, logs, machine logs. That doesn't make sense after a while, so I need to expire the data. So that can be done. Unique indexes. A field must be unique. If example student ID should be unique. So if I create a unique index on that field, it will only accept the unique values. Okay. So this two I never ever used in my career, but I'll talk about the hash indexes. Let's go one by one. Single field index, I don't have to explain. You create index on the one name field, you read that name field in the condition till use index. Straightforward, nothing much. But this is important. Embedded field document. So single field index, double field index, it's okay, but embedded field means I discussed this point in the beginning. Do I have the data? Let me see. Show collections. db.employee. We do have, I guess. We don't have. Just a minute. We did that data. If you DBA, I'm switching the database to see that collection we have or not. Student. No, not this one. Not I can enter anyway. This one, nice. We have it. So db.student.find. This one, let's cover this and go ahead. And pretty. Read the data in a more organized fashion. Pretty is a function. So this is how data is here. Student one, sorry.
Student one.
So we have two records enough to understand anyway. So now, if I wanted to read the data in the form of where street, I'm going with the condition street all the time with my condition. Okay. So now what I'm going to do, db dot student dot when I'm reading it, how do you read embedded documents in fact? Okay. So you always call the right side the parent field. This is a parent, child field, innermost child, all that. So how do I call here address dot, you have to keep this in quotations, single quote, in fact, single quote, address dot street. Okay? Street. Here I'm giving the the street name here, this one exactly. So this was discussed Poonam. Actually, you can refer the existing classes. You get this point what I'm trying to talk. Embedded document, a document inside a document. We discussed this in the beginning itself in detail. So I'm calling the parent field, then child field. It is like a database schema table kind of thing. You are giving the hierarchy. The same thing here. DB means here database always, and you're calling the collection. Then you're calling the parent field, child field, like that. Anyway, if I execute this one, oh, something went wrong. Maybe street, STRET, address. It should oh come on, what I'm doing here. It should be one, not that. Right, you got one document. So here, what I need to understand here is one record I'm getting, but in the background, it is reading both the records. We have two records here. Just for the use case, we have only two, but it is reading all. Why? Because you don't have index on that combination, what you're reading it. It is reading two documents and giving you one document. It go in the collection scan. This itself is bad. I don't have to look at how many it examined, but it's good to see that how many records you have. Like you have only 100 records, it examine all 100. There is no great impact on that one because you have less documents. That's why we see the total examined as well along with the collection all the time. How many returned? Only one. So what I'm going to do, db.student.student1.find pretty. I'm going to create a index on that combination, like embedded document, indexes. Like it is like also single field index. This is not a great difference except that calling two fields. db.student1 dot create index. You have to call that hierarchy, nothing else. So in the indexing here, address dot street, sorry, street. I'm going to create the index like this. So the index only works on this combination address dot street. If I go to the address dot locality, it won't use index. So what is the criteria you are following that matters? What is your search criteria? And you're going on the locality as a search criteria or street as a search criteria? So if you are going with both, example, address dot city dot one comma address dot locality one, two fields I'll cover in a single index. If both are giving as a condition, if both are separate conditions, separate index, there is no other way. So now I'm creating the index on that combination of the parent field, child field. Whenever I read this combination, will follow the index because index is there. Now if I go and see the execution plan here, it will only read one document. It is that simple. It is like a single field only, but you are giving the hierarchy, how you are reading the and reaching the data there. You guys following what I'm trying to say? Say something. You're following or not? See, one
Yes, yes,
index
right.
is yeah. If you look at this one, address street one. So if I am reading this one xxx whatever it is, I had to create the index address dot street one. If I have to read also, I have to go through that entire hierarchy to reach this one. So now again, db dot student one dot find here. Right side you give the quotations address dot street dot street one. I'll give the quotations here. Fine. If I read this one, you get only one record out. Uh, why it is not giving? Any spelling mistake? Address dot street dot
There is no
street
street.
two.
Street one is there, right, in that one? Oh, sorry,
No,
street
no,
is
you
there.
have the
Street.
address street. You have, but something we
Yeah,
missed
yeah.
here. ADDRESSTRETT1. What is the missing piece here? We should get that record for sure if we are calling the right way.
Yeah, here in street 2,
Semicolon.
yeah,
Semicolon.
you use
Double
Where?
quote.
in street
Address
1, you
before.
use extra T, last. Street 1.
Uh, one.
It is
Oh,
only street 1.
oh, street.
History one.
Oh, wow. Come on.
History one.
Nice, nice. Thank you, Pawan. Yep. You are so right. That's good observation, in fact. Yeah. So you have to match the field unless it doesn't know it, right? So that's very nice observation. Thank you. So if you see this one, you got it because you are calling the hierarchy. So whatever the hierarchy you are calling, that is what is your index is. So if I'm creating index in this combination, address dot street one one, that ascending order index. It will create the index. Whenever I read this combination, exactly read how many fields are matching with that criteria. in that entire hierarchy. Okay, this is called embedded single field index. Okay, in fact, so that's what this is, one thing, indexed on embedded field document. So when it is reaching, see here, details dot publisher, details is a parent field, publisher is a child field inside, in fact. So you're covering two fields here in the index. So when I read this combination, I get the data uniquely. I don't have to scan unnecessary data. So this is how it is in index on embedded field. Is it clear to all of you? Say something. Clear, right?
Yes, yes, yes.
Fine.
Yes.
Let's move on. Compound index, I just talked about. All this is a compound index. Whatever I discussed here is a compound index. These are all combinations are compound. More than one field is a compound index. One field, single field, more than one field is a compound index. More than one means it can be two fields, three fields, 100 fields. It should be more than one. That's it. So how it works, we have seen, we spent all our time here. So I'm not going to talk about this. This is something important. Prefix. Prefix means index prefix. See here, when we read the data from collection, we need to add first field of index to utilize the indexes to read. This is only one point I want to cover from this slide. The rest are all covered anyway. So the combinations are all these combinations with this one single index. These many combinations can be used with single index to read the data with an efficient plan. So this you need to educate developer when they're doing it. Okay. Now, this is something that is done. Sort. Sort is something very important. What is the version it is? Version 4.4. Okay, okay, 4.2 good enough. So, do I have the index on this? Wait, I'm reading it. I don't have. So what happens in that case if I don't have? It read both the records. Okay. I'm giving the sort also here. Okay, I intentionally want to give the sort. Well, you don't have to come to here. Let me go to the next. Wait. To talk about the sort, I need more data. That's why. Collections db dot. Is it student, right? Student dot find. It understand the sort. I'm reading S number. I'm reading on S number. S name, in fact, which does not have index on that field specifically. S name, Pawan. So what happens? I'm reading that. I'm going to sort it. Sort. I want to sort the data. I don't even want to give the condition, whatever it is, doesn't matter. I want to sort the data. Sort the data on what? S name. S name 1. So the condition I'm not giving, I can give any condition, doesn't matter. Whatever the data comes out, after coming out, data will be sorted. So I wanted to get all the data. But it is see that T, P, and then L, the data is not in the order. It is going to sort the order. Very good. So if you see this one, G and L, P, R, S, T, V. The order of the data is in the alphabetical order. If I give the same thing instead of that one -1, it reads data to higher to lower, ascending, descending, right? Ascending means lower to higher, descending means higher to lower. So good enough. You're sorting the data for your convenience. Example, I'm giving S name Pawan. Such a case. So Pawan, I don't have to give to talk about that, which is okay. So now I'm sorting the data. S number. How do I cover this up? Mhm. Hmm. Anyway, sort is if you are getting the more data for your condition and that data is sorted, okay, But the condition whatever giving, whatever it is, let's go with the still you don't have index, it works. What I'm trying to say, what I'm going to point out. I'm reading this. I read the execution plan. It read all the documents. That's the nature. Then it sorts the this Pawan record if at all it is there. Okay. Okay, fine. So there is one thing I wanted to point out in the execution plan. When you give the sort operation, there is one extra thing it will come. Mem limit. You see this mem limit? Memory limit. Memory limit. There is a limit. It is using 487 bytes, but these many bytes you can use. Okay. Generally, it should be 30 MB. Is in bytes divided by should be 100 MB. I feel divided by 1020. It is in KBs now. Divided by 1024. Oh, sorry, 1024. 32 MB. So if you are sorting the data, sort is very expensive if you don't have index. Very, very expensive. How? Here, come on, any diagram has the data there. Okay, here is an architecture, good enough. Application is calling one entire collection, okay, or one conditional data. First thing is it has to read all the data into memory. First thing, without indexing, I am talking about collection scan. Then it loaded all the data here. Again, all data it has to sort. So twice compute power it needed for a sort operation, not just one. You're sorting some data. You're sorting some data on name, but name itself does not have a collection index. It went with a collection scan. It reads all the data of student into the memory. Then it sorts the data. Sorting is another compute power you need. You're loading it is bad data, of course, but again you're sorting it. So your one single query is enough to kill the entire Mongo server. So whenever you sort the data, a non-indexed field, it is a non-indexed field, there you get the memory limit equivalent to 32 MB maximum you can use. So there is a note I need to write. This is a very important note for the interview. When we sort the data in Mongo on non-indexed field, I'll show indexed field also. First, understand this. A non-indexed field, the memory allocation, the memory limit to the query is the memory limit to the query is uh, 32 MB up to 3.2 version. Okay, up to 3.2 version, 32 MB. From 3.4 onwards. It's a 4.2, not 3.2. Okay. From 4.4 onwards, the limit is limit lifted up to 100 MB. From 4.4 onwards, sort operation without index would take 100 MB. This is mostly asked into a question just to keep an idea on this. So understand this. First, I read name where it doesn't have the index. Sort happened a scan, collection scan, where the collection scan here. Whenever it finds in the execution plan collection scan and the sort is there, then automatically it limit the memory for your operation. Because you should not kill the system with your single operation, right? Where exactly it was, here it is, memory limit, which is up to 32 MB. Now I'll sort the same thing on the S number, okay? which has the index and the first field of the index. I don't have to call this. Still, I use this one s name, s number. That's it. You don't find the memory limit in the execution plan. You don't find it. Generally here it is, somewhere here. You don't find the memory limit because you are sorting on the indexed field. Whenever there is index scan, you're sorting the data. The sort operation is not limited to any memory. It uses all the required memory, required resources, engage all the resources. But if you're sorting the data on a non-indexed field, then memory limit will come into play automatically. You don't have to worry. Mongo server will give the error. Allowed memory is exceeded for the non-indexed field sort operation. It will throw the error clearly if you read that limit. So that's what the point here it says. In memory sort operation can obtain the sort order by retrieving the document based on the order of the index. Sort operation that can use index often have a better performance than no index. If the query planner cannot obtain the sort order from the index, the sort order means you have the sort, you have the data, you have index is sorted the data. It is reading the data from the index, so the data is already sorted. You don't have to sort again in the memory to give it to the application. So index is already sorted, sort no need to sort, okay, on that field. So there what happens? It will not limit the memory as long as you have the index. Okay, see why we need to apply the sort first. When the data is sorted with the index, why we need
Not
to sort it? When you read the data physically, data comes like this. The sort order applies logically to the system, but you want it to play that physically, you have to read the data in the sorted with the sort function. If you don't use the sort function, data comes in this format. Though it is sorted with the index, you did not ask the sort. That's why you need to use the sort. Though index is sorted your data, but when you're reading the data will be read how it is in the physically. It is using the sort only anyway because it knows it. When you use the sort, okay, I have the sort already with index. Okay, take your data in the sort order. Though your physical data is not sort order, but your output will be in the sorted order. That's what the sort means. Clear? Yes or no? Please say something. Don't keep quiet. I'm not teaching myself. You
yes,
did
sir.
understood? Okay, thank you. Thank you for the response. So this is about indexing basics. Anyway, I did not complete this module yet. We need one more class to close this content. So any questions before I stop the video? Fine.